This will be for the con exercise, subtract vectors. So just some notes. If you take a vector and reverse the head and the tail, you get the negative version of that vector. So let's say you start with a vector A. You can see it's pointing to the right. The negative of vector A would be the same exact vector, except you take the arrowhead and put it on the other end. So it's the same magnitude and it's the exact opposite direction. So for subtracting vectors, the triangle and parallelogram methods are the same as adding. Okay, so we're going to go over that in a moment. And what you're actually doing, you actually add the negative. So if you want to subtract vector B from vector A, what you're really doing when you use these graphical methods is that you're adding the negative version of the vector. So vector A minus B is equivalent to A plus negative B. So let's say you have two vectors here, A and B, and you want to use the triangle method to do A minus B. Okay, you need the negative version of vector B in order to subtract it. So you just take the exact same vector and reverse the arrowhead. So if this is B, then negative B would be the same thing with the arrowhead on the opposite side. Okay, and then if you want to use the triangle method, you still use the head to tail method. So start with vector A, and then take the head of vector A connected to the tail of negative B. Okay, and then the resultant vector, you connect the tail of the first to the head of the second. Okay, and that resultant vector is going to be A minus B. Okay, so like I said, it's the same thing as when we added the vectors, but now instead you're just adding the negative version of the vector that you're subtracting. Now the same holds true for the parallelogram method. Remember, in the parallelogram method, you want to connect the tails of the two vectors that you're adding. So I'm going to redraw vector A. And connect it to the tail of the negative version of vector B. So notice the two tails are connected right here, and this is negative B. And you want to form a parallelogram on this. The opposite sides have to be parallel and congruent. So you want to do that and that. Okay, and then you take the initial point and you draw the only diagonal possible from that point, like so. Okay, and that vector will be A minus B. Okay, it's actually the same as adding A plus negative B. Alright, first problem here is a drawing of vectors P, Q, and R. Which equation correctly describes P in terms of Q and R? Alright, let's take a look. So remember, when you add vectors, you arrange them from head to tail, the vectors that you're adding. Okay, so we can see vector Q, the head is right there. And we can see vector P, the head is over here, so the tail is over here. So we have the head of Q, the tail of P, and then they connect with vector r from the tail of q to the head of p. Okay, so that means this right here is adding q plus p, because it's head to tail, and then r starts at the tail of the first and connects the head of the second one, so that's going to be r. Okay, so that's the equation I get from this, but we may have to do a tiny bit of algebra to match their answer. Okay, let's see their answers. So there's only three choices here. P equals Q plus R is not what we got. Okay, so we might have to do a little algebra. Here it says P equals Q minus R. Here it says P equals R minus Q. So it looks like we might as well solve for P, because these are all P equals. So if I solve for P in this equation, I'm going to subtract Q from both sides. Okay, it's just simple algebra. Q minus Q cancels. Bring down the P. And that's going to be R minus Q. Okay, so all I did was simple algebra right there. I subtracted Q from both sides. And this should match one of the answers. P equals R minus Q. That's that one right there. So that's it. Alright, these are the component forms of A and B. Answer two questions. We're going to perform subtraction and draw the parallelogram. Alright, so we want to do A minus B. And remember, A minus B is going to be the same as A plus the negative version of B. Okay, so we're going to need the negative version of B. So if B is negative 4, negative 2, then negative B, you just change the sign. So negative 4 becomes positive 4, negative 2 becomes positive 2. Alright, so all I did here is change the plus minus signs. Okay, changed it on the X and the Y. So we are going to have to start at the origin. Okay, and first I'm going to do vector A, and then I'm going to graph negative B. Okay, so let's look at the graph. Alright, we want to start at the origin, so I'm going to move everything out of the way so I can start my 1 point at the origin. Alright, and now for vector A, we want 3 on the X, negative 1 on the Y. So I'll take this first arm right here that's connected to the origin. Alright, I'll go 3 on the X and negative 1 on the Y. So this right here is vector A, and then negative B, 4 on the X and 2 on the Y. So you want to make sure you take the other arm that's connected to the origin. Okay, I'm going to go 4. Let me see here. I'm going to go 4 on the X and then 2 on the Y. So this is vector A. This one is negative B. Okay, and basically you want to take this point and make a parallelogram out of it. It looks like it's already a parallelogram, but one thing you can do to make sure is just add the two vectors. Okay, so I have A and negative B. If I add them, I am going to get A minus B, because I'm adding negative B, A minus B. Okay, so 3 plus 4 is 7. And negative 1 plus 2 is positive 1. So that's going to be A minus B. And I think we have it already. 7 on the X, 1 on the Y. Okay, 7 on the X, 1 on the y. So this is it right here. This would be your resultant vector using the parallelogram method. Alright, so we have our parallelogram, and now I think they're just going to ask us this in the box. Let's see. A minus B. We did that. 7 comma 1. So just click in the box, type 7, and then 1. 7x, 1 for the y. Alright, here they give us the components of vectors p and q, and they want us to subtract p minus q. That's very easy. Okay, you just subtract the x's and the y's. Negative 1 minus negative 2. Negative 1 minus negative 2. The two negatives make it positive. So that's just 1. And then negative 4 minus 2. That's going to be negative 6. So we have 1 comma negative 6. Alright, so just type that in each box. Okay, so they give us the components of vectors A and B. Jay and Kwame tried to find the difference A minus B, and Jay subtracted using the triangle method. Kwame used the parallelogram. Who made a mistake? So I'll show you the easy way first, and then I'll explain it. So they want us to do A minus B. Alright, so I'm just going to do A minus B first. Negative 2 minus negative 6 is the same as negative 2 plus 6, so that's 4. And negative 4 minus negative 1 is negative 4 plus 1, that's negative 3. So that's going to be A minus B. So J did not get it correct. Okay, we want 4 negative 3, and J got negative 4 3. So J is wrong, and if we scroll down, Kwame got 8 comma 5, but we want 4 negative 3, so Kwame is wrong as well. So really both of them, it says who made the mistake, both of them made the mistake. Alright, so let's see what they did wrong graphically. I did it the easy way, but let's see what they did wrong. Here, J is trying to subtract A minus B, but you want the negative version of B, not the negative version of A. So that's where J made the mistake. He did negative A instead of negative B. Let's look at the other method. Okay, Kwame used the parallelogram. He constructed it correctly. Here's A, here's negative B, and they're connected with the tails. So that's correct right there. However, when you draw the diagonal for the parallelogram, you're supposed to start at the tails. So this right here would have been the correct diagonal for A minus B. He started at the wrong point and drew the wrong diagonal as a result. So that was the mistake that Kwame made.